Here's another random Computex intro. We're gonna go look at some more technology stuff. It's another day at Computex. I've forgotten what day it is because my sleep schedule's not exactly been normal, but hey, it's fine. The sun is up. It must mean it's daytime. I'm good to go. Let's go to Let's Computex. So I'm here at Gigabyte, and they've got several things that nobody else has other than Zen 5 servers, NVIDIA's solutions, and solutions for open compute. Let's take a closer look. I literally just walked in the door and already it's like super duper crowded because AI, everybody wants to see what Jensen's up to. It's the Gigabyte booth. But the socket for the Intel Xeon, let's take a closer look at that. The 6900, I don't even have hands-on a 6900. I'm here at Gigabyte. They have accidentally shown the first Zen 5 servers. Zen 5 servers? It's technically AM5. It's going to be a Zen 5 server because you're going to be able to put a Zen 5 CPU in here. You're going to be able to put a 9950 in this rack mount configuration, or this even more rack mount configuration with its redundant power supplies that are hot swap, plus its hot swap connectivity at the front, plus its more enterprise layout in terms of the motherboard, and you've got a lot more PCIe connectivity as well. This is pretty much my dream AM5 layout in terms of PCIe connections through to the CPU lanes, and in a pretty standard 1U rack mount configuration. So 9950X, Zen 5, this is your first Zen 5 server. Good job, Gigabyte. Gigabyte is making stuff for Intel, they're making stuff for AMD, they're making stuff for ARM, they're making stuff for NVIDIA. I mean, when you win the lottery like NVIDIA has, it's basically a license to print money. You need all the partners you can possibly get, and Gigabyte is one of those partners. Jensen has been here to sign cases. Pat Gelsinger has been here to sign cases. Lisa Su has been here to sign cases. Gigabyte is making all of the hardware that's going to make the AI revolution possible. So we've got the Grace Hopper, we've got the Blackwell B200, we've got stuff for cloud computing, we've got stuff for edge computing, we've got even Zen 5 based servers. What? The R123X00, this is an E2400 Xeon system, but this is, you know, small and compact, and you can do a lot with this. You've got front SATA, and then here is the AM5 version, the R133C10. Now this is not the motherboard that we were looking at before, this is a custom rack mount layout, but you get the full hot swap power supplies, and they're going full enterprise mode here. This is more like what you'd expect from having a true epic CPU on AM5 versus recycling the desktop parts like with the ATX version, but there's nothing wrong with this. This is a small short depth thing. You've got dual SATA, you got optionally some connectivity here. You could run U.2, you could run dual SATA over here, but you got a hot swap here, which is maybe a little nicer. You got your non-redundant power supply, but again, for this kind of a platform, this is really good. You got your X16 half height full length slot, so there's a lot of possibilities that you could do with this in the data center, in the telecommunications rack, and 16 cores of AM5 goodness in this. You know, this is going to get Zen 5 before the server. Like, this will be the first Zen 5 server that you can run because those are out in July. Gigabyte's also in on the water cooling with both an MI300 and B200 system configured here for liquid cooling. And basically you manage the liquid cooling at the front of the chassis. It's configured in the front of the rack here. And this is how you do 8 GPUs in this much of a physically compact chassis. Water cooling in your data center. It saves power because you don't have to use as much electricity to move air. It's actually less energy, but the infrastructure for water cooling is a little trickier. Gigabyte's got it figured out. All the other B200 chassis, they're all 8U because they need air cooling. This is double the density because it's water cooling. That's the difference water cooling makes in this kind of a scenario, because this is where we're headed with this type of density for AI. Because businesses are making a lot of money on AI, so it should be good for people, right? So this is the H374A80. This is Intel's big Xeon platform for Xeon 6. Look at this monster. Okay, so this is configured with 4 nodes in a 3U chassis, but it's Xeon 6, 12 memory channels, and you're gonna have all the PCIe expansion. But look at what they've done for the layout here. It's incredible that they're cramming all of this in. This is designed for the big P-core monster CPUs, 128P cores or 288E cores per socket. Yeah, 24 memory channels in this layout. And check out this socket. Look at that. That is an incredible pen density. I can't even believe it. I can't believe this is what is becoming the high-end server platform. This is just truly a marvel of engineering. All the NVMe connectivity up front. You got 4 banks for each of 4 nodes. So it truly is incredible density on the H374. Now, not to be outdone, if you need something a little bit more pedestrian, you've got the GPU option for the Intel 6 platform. That's the G294S42. This is a little bit more mainstream, but you can run, you know, your 8 memory channel Xeon platform. This will work fine with the Xeon system, the Xeon 6 CPUs that I reviewed, and you've got 8 full height, full length Gen 5 X16 GPU slots. Gigabyte's also gotten creative with their memory channels here. You can do 2 DIMMs per channel on some of the channels. So they used every square millimeter of board space they could so that you could run extreme memory densities, but this is still just an 8 memory channel platform. But this will run great with the 6700 series Xeons that I just reviewed on the channel. If AMD EPYC is more your speed, check out the H253Z10. This is a 2U 4-node front access system, but look what they've done for the board layout. It's still front to back airflow, but they had to get a little creative with the layout in order to be able to do 2 DIMMs per channel. This does support a 400-watt CPU, so you could run Bergamo in this. And with 2 DIMMs per channel, you can do extreme memory densities on this platform. You've also got MCIO connectors for extra accessories, and your full PCIe 5.0 by 16 expansion slot, plus your OCP3 interface, and dual E1.S. The data centers of the future are insanely dense, just like me. This is the H273Z80. This is a 2U 4-node system. It's got a little bit more standard layout, but it's 2 sockets per node, 12 memory channels per node. You got dual PCIe Gen 5 plus your OCP3, plus you got extra connectivity scattered throughout the board for different configurations. So Gigabyte is really packing in the density here. Look what they did for the M.2 on this one. There's 2 M.2 stacked, but they're overlapping. So this one's taller and that one's shorter. And they're not one on top of another, so you get good airflow, but they overlap. This is mad. Like, what sort of genius did this layout? And last but not least, the R264AG0. This is Xeon 6. This is the perfect platform for the 250-watt E-core system that I looked at. Look at all this room for activities that you have in here. This is meant to be a normal storage server, so you can pack in some of the new insanely high capacity mechanical hard drives. 32 terabytes up to mechanically. We're seeing on the floor here, I don't know if those are hitting general availability, but mechanical hard drives that are 32 terabytes each is just, I guess that's where we are in 2024, but this is the platform for it. Gigabyte was also showing off the R163P32. This is the Ampere 1 single socket family. If you're ARM curious, I would encourage you to check out this model, the R163P32. This would be a good system to start with. Pick up one of them and see if ARM is going to work for your enterprise. If you're ARM curious, is that a TRX 50 board with 8 DIMM channels? It's not 8 DIMM channels. It's 4 memory channels, 2 DIMMs per channel. Your memory bandwidth will suffer because your clock speed will be not quite as high, but being able to run 8 DIMMs on TRX 50, that might be pretty sweet. Gigabyte is also embracing Broadcom, so we've got dual 25 gig, dual 10 gig, and dual 1 gig, just in case you need some connectivity to a specific VLAN or something. Then you've also got your Broadcom SAS 3808 RAID controller. So this is the tri-mode stuff that will do PCIe Gen 4 or SAS or SATA, as well as the PCIe variants here for connecting to the front I/O backplane or your drive cages or whatever you want to run internally. Because some people still want to run SAS. I mean, you can get high-performance SAS flash, like SAS 24 is reasonably fast. But networking connectivity, 25 gigabit Broadcom, native from Gigabyte. They also have motherboards that they're showing off. Genoa, Milan, Intel Xeon 6, and Sapphire Rapids / Emerald Rapids. It's basically the complete lineup. It's so cute. Look at that. With its X16 and its X4, the optional 10 gigabit interface, This is ECC UDIM, not RDIM, but this will run with the 7900 or the 7900X or the 7950X or the new EPIC 4004 systems. M.2 connectivity, front SATA, AM5 is where it's at. Now, one of the reasons the Phison booth is so busy is because everybody is interested in AI adaptive. What AI adaptive does, and this is what we saw at the ASRock booth with the 8 GPU system, and that's why ASRock is physically doing cards that have a blower, the 7900 XTX, is even though those don't have a lot of VRAM, Phison is using their SSDs, their really high capacity SSDs, in single level cell mode so they don't wear out, they don't shred quite as fast, and they're using a bank of SSDs as VRAM. So it's direct access over PCI Express, but you can train models that require a terabyte or two of VRAM with a bunch of Phison U.2 SSDs, or even high endurance M.2. That's AI adaptive, that's what the software does. So it unlocks the possibility to run things that need a lot of VRAM. You don't have a lot of VRAM, even on PyTorch, even on the AMD stack. So that's why you literally can't get in at Phison. So what we're looking at here is a desktop platform with a Gen 5 breakout cable, with the Gen 5 Apex Storage X16 Gen 5 with a Phison E26 and a ton of Phison Gen 5 storage, 51 gigabytes per second on FIO. Gigabytes, I guess, but yeah. Still, that is absurdly fast. And Phison was showing off a lot of new stuff with their new SSD controllers and their new SSDs and even redrivers and retimers for PCIe and PCIe accessories. This will be critically important if you want to run U.2 or enterprise storage in your desktop, because you can just get an add-in card that does redrivers or retimers, or maybe a cable with a built-in retimer, and you're going to be able to run that Gen 5 storage a heck of a lot easier. For me, I want to do some more testing with the Apex storage solution, because that is a lot of Gen 5 M.2 on that single carrier card. And it is technically passively cool, even though those are big ass heat sinks. But still, that is really, really fast, and that's at Phison. Now you might have heard of the Phison brand, but what about Phison's enterprise brand? Phison's enterprise brand, that's Pascari. Pascari is making E1.S, E3.S, and U.2. Now why does Pascari want to do that? Why do they want direct access to enterprise customers? And it turns out it's because there's a lot of opportunity for innovation in enterprise storage, because you can look at the workload, change the way the controller works, maybe deploy a more powerful enterprise storage controller actually on the NVMe, and the NVMe looks at it and says, oh, you're doing OLAP, oh, you're doing database workloads, oh, you're doing this, that, or the other. It will actually fine tune how it deals with that workload in the SSD, which is wild. I've never met a company that needed more of a marketing glow up than Siphorex. They've got the goods, they've got a real product. They've got, okay, so Intel Xeon runaway power. The inside scoop is that Open Compute said, no, we want 500 watts a socket, you got to stop at 500 watts. But what they've got is a multi-phase cooling solution. So two-phase, you have a liquid and a vapor phase. And so you have heat sinks that look like this, because it's multi-phase. Think vapor chamber, but it's not vapor chamber, not exactly. It's a multi-stage cooling solution. And so you end up being able to do a ridiculous amount of cooling in a very, very small area, because you have all of the heat being carried away by the stuff in the heatsink. And so they've got this set up for the ridiculous, like 700 watt Xeons that probably aren't going to come, but for 500 watt and beyond, pretty soon we'll have Threadripper maybe, possibly. That would be amazing. But yeah, Siphorex. You got to check out the diagram and understand the chart here. Like, they should just blow up the chart and make it really huge, because the chart shows them winning. The cooling performance on the chart is off the charts, and so this is a really exciting technology. I hope we get a little bit more hands-on. We see a little bit more of this in the market, because this is needed. We needed this like a generation ago. So this is actually pretty exciting because it's new technology. Like, this is the unvarnished new technology. It's amazing. How's it going? The whole reason I'm an MSI, CXL memory expansion that works. Look at it. It's glorious. It's so glorious. Look at what's happening. MSI is in the server game, and they have CXL memory that's functional and works. What is this? So MSI is launching a server. This isn't available yet, but this is the S2301.
Yes.
That's dual socket Genoa/Bergamo.
Yeah, so SP5 that next Genoa, Bergamo, and we'll have drop-in support for the next generation once that comes.
Looks like you got 2 PCIe 16 full height, full length slots, 1 PCIe 5 OCP3 slot. A-speed for your management. You got 8 E3.S 2T. They are CXL compatible. Those are the ones on the side here. And then you've got PCIe Gen 5 storage at the front in the E3.S format.
Yep.
So this is a pretty interesting, mostly normal looking rack mount server option, but from MSI. That's wild. DCMHS, that's open compute terminology. And DNO, this is density optimized. FLW, full length, because that's a thing that you have to worry about with racks. This is nice. It's very nice.
And then the compute node stuff, so there's DNO Type 2, which is the half width, and DNO 4, which is the bigger one.
So DNO 4 is larger, and then DNO 2 is half width. So theoretically, you could probably get a 2-node in this, depending on what you do creatively for your chassis.
Yeah, that's what we looked at earlier.
So this is that's what you got to do for 2-node. There's no room for activities. It's all so tiny. And then of course, the premier Zen 5 server. Technically Zen 5. So MSI has not one but two, the 3051 and the 3052. Look, SFP28. Right, this is, oh my gosh, you got all the slots, SFP28, AM5. This is like the perfect EPIC 4004 motherboard, up to 170 watts. This, yes, yeah, I need it. It's based around the Intel E810. I bet Intel frowns upon that.
Put the Xeon E over there.
Look, it's a Zen 5 motherboard with an E810 built right in, dual 25 gig, AM5. I want to put a 9950 in this so bad. And then of course the 3051, which is a dual 10 gig, but it's pretty wild that MSI has got these boards. You could drop a 7900 in here. You don't need an EPIC 4004, but you could put an EPIC 4004 in here, up to 192 gigabytes of memory. No, you could do 256. Oh, they'd probably be a little slower. I need to test that, but I know you could do 192 for 48 gig DIMMs. I'm a METAC, Tyan. That's how we review them on the channel. They've got all their Xeon 6 stuff out, and all their Xeon 6 stuff that supports an NVIDIA ecosystem. Yeah, check out the FT83B B7149. Up to 8 GPUs, two 350-watt Xeon 6 CPUs, and in a very attractive rack mount configuration. So this is 16 memory slots per socket, so you've got 16 plus 16, that's going to be up to 4 terabyte RDIMMs in DDR5 6400. So this is also set up for the H200 NVLink. So the new difference is that you can cross-connect up to 4 GPUs with the bridge. There's a bridge that would go here and you'll have 2 GPUs. And so this is going to be a ton of GPU connectivity in this chassis. You can see we've got a mezzanine board here with our Gen 5 connectivity or Gen 5 breakout cables back to the motherboard, and then our dual Xeon 6 configuration with DDR5 6400. Now DDR5 6400, it's going to be a little slower if you're at dual 2 DIMMs per channel, but up to DDR5 6400 is a ton of memory bandwidth on the Xeon 6 platform. And you still got some pretty good storage options at the front for NVMe and anything else that you might want to run for local storage, but you've also got a ton of PCIe 5 for your network or your fabric connection. So from Fox Creek to Deer Creek, this is the Xeon 6 next generation successor, and they're showing it off here at the booth. You got all the PCIe connectivity. You could run GPUs in this, right? Yeah, this is configured for GPUs. You got plenty of room here for airflow and everything else. 350 watt Xeon 6. You got dual OCP3 slots. You got 4 PCIe Gen 5 X16 slots, and you've got 24 U.2 bays at the front. Everything is PCI Express 5. Everything. This is how you do 288 cores. They also have a 1U configuration that is single socket, so you can also run your 350 watt Xeon 6, so 144 cores in this configuration. But you got 4 options for expansion: 2 X16 PCIe Gen 5 slots, full height, and then you got your OCP3 slots as well. Plus you've got your remote management card there. You got a couple of unused MCIO connectors, but the MCIO connectors at the front are going to connect to U.2 right in the front of the chassis. And this configuration I think will be popular in a lot of data centers because it's reasonable density, it's 350 watt, good cooling, got lots of U.2 connectivity and lots of flexibility for what you're doing for your network storage. And of course, if you prefer to do your own or do your own experimentations or do your motherboard, they've got several Xeon 6 based motherboards. And so this motherboard is for our Xeon 6, but then we've also got, you know, Emerald Rapids and Sapphire Rapids. If you see a deal on Emerald Rapids or Sapphire Rapids CPUs, or you want to build something that's experimental, you've got that option in single and dual socket configurations. Of course, they've also got AMD boards as well. The MI300X, now the MeTAC edition of the MI300X. This is Open Compute. This is the power of Open Compute. Open Compute is helping drive this level of standardization. Today, 8 MI300s. 8 MI300s in this chassis, but tomorrow it could be MI325X, it could be MI350X. That is the standard. That is amazing, because that means these chassis are going to be upgradable, and they're not going to be e-waste, and you're going to be able to use them for 5 years on end, even as you swap GPU modules. And the kinds of gains that we're seeing gen on gen, it's 5 times faster, it's 20 times faster, it's 35 times faster. As you move gen on gen on gen on gen, that gives you an upgrade path to where you're not completely replacing everything every time. The MI300X Instinct from AMD in this chassis. So this is a cloud gaming server. This is basically the kind of chassis that Google was looking for when they were running Stadia. So this is AM5, but it's AM5 with extenders so that you can put your GPU in the front. So you could run a 4090 in here, you know, a special OEM built version of the 4090. You get the power supply connections for that. And then this is your AM5 system. So 8 cores, 16 cores. You could run the gaming X3D CPU, standard desktop memory, and manage it all from a central control dashboard. There's 5 of these in a single chassis. This is the HG68B8016. So 6U, 5 nodes. These are all independent systems. They don't have any kind of special interconnects or anything like that, but this is really designed to host large power-hungry GPUs, one per system. And this is what you could run, you know, a cloud system remotely, and then do your Moonlight streaming or something like that. If you only have like a handheld that you run for gaming, you can run a system like this in a low latency cloud and do your own Steam in-home streaming, or data center providers can offer that service with a chassis like this. I also decided to swing by FSP Group because they make the best standard ATX dual redundant power supply. So if you've got a nice rack mount case and you don't want to use a proprietary mounting power supply and you want an ATX power supply that even has management bus interface, you can definitely do that. And they've got that they're showing off at FSP Group. In addition to showing off new, even more efficient models of power supply, they've got a few home charging accessories, solar accessories, and everything else that we checked out last year, so it's a lot of fun. It's a tower case with wheels. That's a case after my own heart. Patriot has 3 classes of Gen 5 SSD, with their fastest performance one being 14 gigabytes per second and up to 12 gigabytes per second to write. It's got a built-in blower fan, and you've got a standard fan connector, or standard fan adapter, I guess, bundled with that. But this one is going to be a DRAM-less Gen 5. It's Maxiotech. And so this is maybe going to shake up the market a little bit with a better price to performance ratio. But these are some Gen 5 SSDs I'm keeping my eye on. And then of course they've got a 2230. So if you want to do a 2 terabyte Steam Deck upgrade, this little guy can do up to 5 gigabytes per second. So it's Gen 4, but it's still low power. Most people don't realize how important low power is when we're talking about 2230. So you want something that's not going to generate a lot of heat and not drain your battery faster. And so that is a design goal with 2230s. So maybe this is something I'll try in my own Steam Deck. Maybe that'll be really good. I did sneak on their laptop so I could do Crystal Disk Mark, and I'm getting between 3.7 and actually 4.069 gigabytes per second. Again, the limitation with Thunderbolt 3/4 is like 2.2 to 2.6 gigabytes per second. The fact that I can do 3.7 gigabytes per second read and write on their external USB 4 SSD is very, very impressive. They were also showing some other portable SSDs. The Patriot iLux. This is a metal USB SSD. Now this is not USB 4, this is USB 3.2 Gen 1, or Gen 2, I'm sorry, 10 gigabit, but it's got pass-through USB-C charging. This also works with my camera. So a lot of cameras that have like record open gate to a USB-C interface because an SD card is too slow, this works with that. I might have destroyed an SD card testing that because the SD card could not keep up. But with this works great. So this is available in 512 gig 1 and 2 terabyte capacities. We've also got this one which has got a built-in AirTag. So if you want a built-in AirTag so you don't lose it, that would be good. And then they've also got a USB-C charger. This charger has a terabyte of storage and will back up your phone overnight. Now, Apple is weird about backing up over USB-C, but with Android it would work pretty great. And you can also enroll multiple phones so that you can download the pictures off of something else. They've got an app for that. I thought it was neat. I just wanted to mention it. That's another Computex down. There's so much stuff, it's overload. There's so much stuff that I didn't have time to put into a video. Man, I gotta bring a crew. I'm gonna bring a crew. Like, favorite, and subscribe if you do. Also share all the links and click on all the stuff, because I don't know. It's a pretty awesome thing. All right. I'm signing out. You can find me in the Level 1 forums as soon as I catch up from the jet lag. I'm signing out and I'll see you later.